please join me in welcoming Rob Scott telling us about a simpler approach to how to access control in Kubernetes. Woo!
Thanks for that introduction. My name is Rob Scott, as he said, and I'm going to be talking today about smarter Kubernetes access control, how we can simplify our approach to authorization inside Kubernetes. I work with a great team at ReactiveOps, and at ReactiveOps we get to see a wide variety of Kubernetes clusters from a wide variety of organizations, and what that's led to is us learning a whole lot about how to do authorization effectively for a whole different host of organizations and a whole different host of sizes. And we're going to try and share those lessons with you today and some tools that we've built to help simplify that process. So the outline of today's talk is really simple. We're going to start off by going through some challenges of authorization and then go into a quick recap of RBAC basics. So if you came to the talk and aren't familiar with all the RBAC terminology, I'll just take a couple minutes and go through the basics of RBAC so the rest of the talk makes sense to everyone here. And then finally, most of my talk is going to be focused on two distinct areas. One is understanding who has access to what inside your cluster, and then, maybe most importantly, managing RBAC simply and effectively. All right, let's get started. So first off, I think we can all agree that authorization is challenging. Authorization systems often feel either way too simple or way too complex. How many of you have ever been frustrated by an authorization system that was so simple it didn't let you do what you wanted to do? Anyone? Okay, that's plenty of people. And on the other side, how many people have been frustrated that an authorization system is just way too complex and just way too overwhelming? Anyone? Okay, yes, so plenty of the same hands for both, and that's the case for me as well. I've seen authorization systems that feel way too simple or way too complex. And it's really hard as a developer of an authorization system to get that balance right. And that balance is going to be different for every different organization and use case. And unfortunately, authorization is one of those things that's only really noticeable when it's getting in the way. How many times have you heard someone say they really love their authorization system? Anyone hear that ever? Okay, yeah. So it's just not something like I've heard, I don't think ever, because authorization is not something we're thinking about until it's getting in our way. It's not something we're thinking about until we're just annoyed because it's not letting us do what we want to do. And unfortunately, authorization finds itself in that no-win position where if you think about it, you're just getting annoyed by it, and if you don't notice it, you don't give it any credit. So even the best intentions, unfortunately, can still end in failure. Organizations start with these perfect ideas, these perfect goals. We're going to have the most granular policies. We're going to do everything by the book. We've gone to KubeCon, we've listened to the talk, we're going to do everything perfectly. And then at some point, real life happens and somebody has this urgent need to get access to this simple resource. And can you just make this one temporary exception, just once? I promise it's only going to be this one time. I really need to get into this, and I need it now. And so you make an exception, and you do this one thing. And before you know it, your authorization system that was once perfect is just full of temporary solutions on top of temporary solutions, and your best intentions ended up in failure. And Kubernetes itself comes with its own unique challenges. Users and groups are not actually managed by Kubernetes. How many of you have tried to do kubectl get users or kubectl get groups just to get a list of users, as an example? And yeah, I mean, I've tried that. And you don't get any kind of response because that's not how Kubernetes auth works. Your users and groups are coming in from your authentication provider, which is often coming from, let's say, Cloud IAM or an OIDC provider, or whatever it happens to be. And so users and groups don't actually exist as resources within your cluster. And this can be helpful and really great for your authentication system and the simplicity there, but when it comes to authorization, it does complicate things a little bit. And then the other bit, if you've tried to scale out Kubernetes RBAC, you realize that at the beginning, it works perfectly, and then as you scale more and more, it gets more and more complicated and harder to manage. And that's something that we found at ReactiveOps, that as we're trying to scale this out across larger organizations, it becomes really challenging. Okay, so now that we've gone through those challenges, let's try and understand some basics of RBAC, just if you're not familiar with all the terminology, I just want to go through some basic terms so the rest of this demo, the rest of this talk all makes sense. So the first terms worth understanding when it comes to authorization in Kubernetes are roles and cluster roles. After all, RBAC stands for Role-Based Access Control. So roles and cluster roles define specific sets of actions allowed in Kubernetes. And maybe the best way to explain this is to show you an example. This is a role inside Kubernetes, and in this very simple example, it allows us to list deployments. And it's available in the dev namespace. So this allows us to list deployments in the dev namespace. You can see the rules down there that grant that. Now we're going to switch to a cluster role. And if you blink, you'll miss it, because this is the only difference with a cluster role. It's almost the same thing. The only difference is that where a role is available in a specific namespace, a cluster role is available across an entire cluster. Now, these are all well and good, and there are plenty of use cases, like for your own custom applications that need to talk to the Kubernetes API, where you want to build out really customized roles that have every single bit of access specified in them. But for user-level authorization, what you'll likely want to use is the default roles that are included inside Kubernetes. And those are pretty self-explanatory. There's view, edit, admin, and cluster admin that all grant a little bit more access each time. And combined, these roles are really helpful when you're trying to figure out your user authorization policy. Combined with a few other things like properly scoping namespaces, this can be a really effective way to keep your authorization simple but still effective. Now, where this all comes together is the concept of role bindings and cluster role bindings. And these are what connect service accounts, groups, or users to those roles. So whether it's a cluster role, a role, one of those default roles that exist in a cluster, role bindings are what connect your users to your roles. So they're a very important aspect in authorization. So let's walk through a really simple example to put it all together. And this example is something we're going to be referencing throughout the entire rest of the talk. So pay attention to the level of access we're granting. So we've got a user. We're going to call her Avery. And she should be able to edit resources in the web namespace and view resources in the API namespace. So to give her that access, we need to create a role binding. So this is a role binding that connects Avery to the edit role in the web namespace. So this allows her to edit resources inside the web namespace. Now we're going to do the same thing for the API namespace, except we're going to let her view resources in the API namespace. So if you were paying attention, I did just switch slides, and all of 2 words switched. So you may notice that this can get pretty repetitive as far as configuration. There's probably some ways we could potentially improve this and make this a little bit more efficient and less repetitive. And that's what we'll be talking about a little bit later on. But first, we need to get into how we can understand Kubernetes authorization. I know a very common question that I've seen within Kubernetes is, how do I know who has access to what inside my cluster? And so in this next section, I really want to spend some time highlighting some tools and practices that can help you answer a variety of questions along those lines. So following up with our example, can Avery list pods? And if so, why? So can any given user list a resource? And if so, why can they do that? That's a pretty basic question when you're talking about authorization. So built right into kubectl is kubectl auth CanI. And this is the most awesome tool for understanding access inside Kubernetes. So you can ask it, can I list pods? And you can impersonate, in this case, Avery. So in this case, I'm going to ask kubectl auth CanI list pods. Now, if you've been paying attention, I've got a question for you. I'm going to run this command, and given the access that we've already granted Avery, it was to edit resources and to view resources in a couple different namespaces, I can tell you this response is either going to be yes or no. How many people think the response is going to be yes? OK, all right. How many people think it's going to be no? OK. How many people have no idea? All right, great. All right, well, we're going to find out soon enough. So I run this command, and unfortunately, I was hoping to get more people to say yes, because I thought that would be a reasonable thing, but the answer is no. Because this command, by default, is asking if Avery has access to list pods everywhere in the cluster. And Avery has access to list pods in a couple places in the cluster, but not everywhere. So what we really want to ask is, can Avery list pods in one of those namespaces? So if we run this command again and we specify, say, the API namespace, so we'll just add a -n and API, the answer we get back is yes. And if we do that again, because we also granted our access in the web namespace, specify a namespace. So remember API? That API namespace, we granted her view access. If we run that against the API namespace, you start to see some green check marks showing up that show, OK, Avery can list a lot of resources. Not quite everything. She can't create, update, or delete anything, but she can list a lot. It's a really, really helpful tool. And then remember the web namespace, where we granted her edit access. If we run this against the web namespace, we're going to see a lot more green check marks, and this shows you what the edit role grants her. OK, so this open source tool is Reques. Don't worry if you didn't catch that. All these will be linked on the very last slide, so you can take a picture of that. These are really, really helpful tools. But sometimes you want to just flip your question around entirely. You have a resource you really care about, and I went too fast. OK. You have a resource you really care about inside your cluster, and you want to know who can access it. It's rare that it's going to be pods. You don't really care usually if someone can list pods, but let's imagine that you care that someone can list or read secrets in your cluster. That's a really common use case for a tool like this. And Aqua Security built a really cool open source tool. I'll warn that they're still labeling this as a work in progress, but it's an awesome tool and already immediately helpful. And it's aptly named kubectl Who Can. So given an action and a resource, you can get an entire list of users in your cluster that can do that action. So in this case, kubectl Who Can list pods is going to show every single user, service account, or group that can list pods inside my cluster. So really cool tool from Aqua Security. And finally, sometimes you just want to get a top-level overview of authorization in your cluster. You just want to see every bit of access that's been granted. And for that, at ReactiveOps, we built a tool called RBAC Lookup. And this is a really simple tool that just gives you that top-level overview of what's going on in your cluster as far as authorization. So RBAC Lookup, in its most basic form, just prints out every single bit of access in your cluster. So it shows you every bit of access that you have granted to anyone, any account inside your cluster. And that's helpful to get a really wide overview, but sometimes you want to dig a little bit deeper. And what RBAC Lookup was really intended for is to look someone up by name, thus the name RBAC Lookup. And so if we type RBAC Lookup Avery, we're going to see every bit of access that Avery has, regardless of scope. So it shows her cluster-wide access, her API access, her web access, whatever it happens to be, it shows it all in one place. And then if you get the wide output, you can see that this bit of access is coming from specific role bindings named Avery. So this shows you not only what access she has, it shows you it in every namespace across the cluster, and then the source of that access. Well, that's all well and good, but sometimes you want to look a little bit wider. So RBAC Lookup matches any pattern, and one pattern that we've seen a lot for usernames is email addresses. So in this case, all our usernames have @example.com. So we're just going to change that around and do RBAC Lookup example.com, and we're going to get everyone in our organization, all 3 people, that have access to our cluster. And so you can see not only does Avery have access, Joe and Sue also have access inside this cluster. So really, really simple tool. But there's one more thing, because sometimes RBAC isn't all there is when it comes to authorization. Sometimes there's a little bit more. And one of the most common use cases that I've referred to before is Google's Kubernetes engine, where IAM is also a form of authorization inside your Kubernetes cluster. So if you're trying to understand not just RBAC access, but your cloud IAM access, we support that too. So you can run RBAC lookup and then add a GKE flag, and you can see their IAM access as well, so you can get a picture of not just their RBAC access in a cluster, but also their IAM access. So for anyone running GKE trying to really understand authorization from 2 different sources, this can really help make that a little bit more clear. All right, so summary of those tools. kubectl Auth CanI is included by default with kubectl. It's amazing. It allows you to see if a user can perform a specific action, and if so, you can dig a little bit deeper and ask why. Reques supercharges that, runs that same API call a whole bunch of times for you, and gets that same information and presents it with those nice green check marks and red X's in an access matrix. kubectl who can flips the question around entirely and answers who can perform a certain action in my cluster. And finally, RBAC lookup allows you to get an overview of RBAC, and if you're on GKE, IAM overview. Well, that's all well and good, but maybe the most important part of this is how we can manage Kubernetes authorization simply and effectively. And so for the final section, I want to walk through some of the lessons we've learned as we've worked with so many different organizations of different sizes for how we can manage Kubernetes authorization simply and effectively. So when it comes to effective RBAC, I think we need to start with the principle of least privilege. And that's don't grant any more access than users actually need. If they ever need it in the future, we can grant it then for a good reason. But if you don't grant any more access than users actually need, you're simplifying life. Less access you're granting is less config you're managing. And then use namespaces effectively. It's so often that we see that a whole bunch of applications are deployed into a single namespace. And that makes sense, but when RBAC starts to come along, you really want to have your namespaces represent your project teams, because namespaces are about as granular as you can configure RBAC. So if you want to be able to grant teams access to a specific application or namespace, it has to be in a namespace. So create names that line up with your teams. And then finally, have a clear update process. Ideally, this should include some kind of automation with CI. This is just my own personal opinion. But at the very least, any changes to your authorization should have a clear update process, and they should all go through that same workflow, whatever works for your organization. And then for simpler RBAC, I think it's worthwhile to centralize that configuration. When there's a question of where does that role binding come from, where does that bit of access come from, it's nice if it's all coming from the same place. What's worked for us is to group all our RBAC configuration together per cluster. So each cluster has a single place for RBAC configuration. That could be different for each organization, but as long as you have a place where you know to go for your RBAC configuration and it makes sense for you, then quite simply, give less people access. In many cases, engineers don't actually need access to your Kubernetes cluster. If you think about it, you probably have CI/CD set up, some kind of automated deployments, and if they can already just push some code and know that it's going to reach your Kubernetes cluster, maybe they don't need to actually be getting into the Kubernetes cluster itself. And finally, use those default roles. Take advantage of them. They're there for a reason. View, edit, admin, and cluster admin, combined with namespaces properly scoped, give you a lot of flexibility with how you set up your authorization. So all of this hopefully can lead to more effective and simpler RBAC. But some of these things are still a little bit challenging to get to. So we built an open source operator called RBAC Manager that can help here. And we built this to help accomplish these goals, a lot of it surrounding making RBAC automation a lot simpler to work with. So RBAC Manager allows us to use more concise configuration by grouping resources together. It allows us to automate RBAC changes. So if you want to put your RBAC configuration into some kind of CI/CD workflow, this allows for that very straightforwardly. And then, as a newer feature, we now support ephemeral namespaces and a whole lot more with a cool feature called label selectors. And we'll go through each one of those and how they work. So deployments simplify managing pods. If you're familiar with the paradigm in Kubernetes. If you've created a deployment, it creates a bunch of pods for you, and it just simplifies that workflow. It's a nice parent resource that owns its pods. We tried to create that same kind of pattern with RBAC definitions, and that's our custom resource for RBAC Manager. And they simplify managing role bindings. So role bindings didn't really have a parent resource before, and they were a little bit annoying to work with, especially at any kind of scale. And so we thought, well, what if we could create a custom resource on top of this that would simplify the management of role bindings? And so the advantage of an RBAC definition is, number one, it's more concise. So if you remember that example from before, it was a really simple example where we gave Jane access, Avery access. We granted her 2 role bindings. That same configuration can fit on a single slide. So instead of 2 slides of YAML, we're down to a single slide of YAML. And usually, if I had more room on this slide, I could show a more dramatic change in configuration. Usually, we cut configuration by around 1/3 of just vanilla role bindings with Kubernetes. So you can cut down the amount of configuration you're using pretty significantly. And I think one advantage is, well, you're writing a bit less YAML. But another advantage of using a system like this is that, to me, at least, it's a little bit easier to read. Because in one place, you can see that Avery, or whatever group, usually this would be a list of users that belong to a specific team, and you can see all the different bits of access you've granted them. So in this case, we can see in one place that we've granted Avery view access in the API namespace and edit access in the web namespace instead of looking through 2 different configuration files. So just to prove that this works, we'll go ahead and apply this RBAC definition, and we can watch the RBAC manager logs below, and right away it creates those role bindings for us. So it just does that for us. We get the same end result. We've just saved some configuration. Well, that's all well and good, but really what I think the key idea behind RBAC Manager is we need a better workflow around RBAC. We need a better way to work with RBAC, manage RBAC, and have this be a little bit more automated. So for RBAC automation, we knew we needed to ensure that newly defined role bindings were reliably created. And the good news is that already worked. That was not an issue. So whatever system we built, we could just recreate that, and it was going to be fine. But the next 2 got a little bit more complicated. Role bindings that require changes needed to be reliably updated or replaced. Now, why would I say replaced? Well, role references in role bindings are immutable, so you can't actually change a role reference in a role binding. So what you would have to do is delete an old role binding and create a new role binding if you were trying to change someone's access from, say, edit to admin. So not the end of the world. There was some kubectl tooling called kubectl Auth reconcile that helped with that. But we also wanted to make sure that that process was very smooth with RBAC Manager. But finally, maybe the biggest one was we needed a way to ensure that we could safely revoke access without accidentally deleting the wrong role binding. Because any kind of automation, you need to ensure that what you have in your code, whatever you're using with infrastructure as code type thing, actually represents what the state is in the cluster. So you need to trust that revocation of access is going to work as you want it to. So going back to our RBAC definition, we're going to try out a couple of these changes. And so in this case, I'm going to go ahead and I'm going to change Avery's access in the API from view to admin. And usually, ideally, this should go through some kind of CI. In this case, I'm going to edit live because it's a demo and this was the easiest thing I could do. But we're just going to run with this, pretend this is a CI workflow. But when this RBAC definition changes, RBAC Manager goes ahead, deletes the old role binding, and creates another one automatically. So it's just one bit of pain that you don't have to deal with. It just works. And maybe more importantly is revocation. So in this case, we're going to go ahead and remove that access to API altogether. So we'll just remove the reference from the RBAC definition. And again, editing live instead of using CI. But if you can imagine this going through a CI workflow, that's what I'm aiming for here. And when we edit this, we can see that right away, RBAC Manager sees that RBAC definition has changed, sees that a specific role binding is no longer desired that was owned by that specific RBAC definition, and so it revokes that. It only touches things that it has created and are owned by specific RBAC definitions. But with that said, we have a really straightforward path to start automating these changes and using them in some kind of CI workflow with pull requests, approval, whatever it happens to be for your organization. But you can now automate your RBAC configuration. Now, maybe the most interesting feature with RBAC Manager is label selectors. How many people here are using ephemeral environments in Kubernetes? OK, a few. How many people want to be? A few more. OK, so this is for you. And maybe there are some other use cases here, too. So if you've ever wanted to have an ephemeral environment system where just a new environment just spins up like nothing for your developers if they're working on a feature branch, this helps solve the authorization side of that. We now allow that we now support namespace selectors. So anytime that a namespace has a label team equals API in this example, Avery is going to get edit access. And again, you can have a whole list of users here representing your API team. But to keep with our example, this is just going to be Avery getting this access. So we're going to create a new namespace. We'll label it demo. We'll create a new namespace called demo, and we'll label it team equals API. And when we do that, if you notice below, RBAC Manager has automatically created that role binding for us, so Avery has the access we want. And finally, if we change that label to another team, like not API, then her access is immediately revoked, and she no longer has access inside of that namespace. So really simple workflow, but if you've ever wanted to work with ephemeral environments, this can help that out. So to recap RBAC Manager, it gives us more concise and simpler configuration that groups role bindings together. RBAC changes are now a whole lot easier to automate, and label selectors allow for simple RBAC for ephemeral environments. Thanks so much for your time here. These are all these projects that I've featured today already. They're all on GitHub. They're all open source. The last two were developed by us at ReactiveOps. We're always open to any kind of feedback, ideas, issues, pull requests, whatever you run into. We would love to make these tools even better so they can make authorization more approachable and more simple inside Kubernetes. I think I might have a few minutes. Any questions? Cool. Thank you.
Maybe you can go a bit into detail what permissions I need to run these tools. So maybe you can start with kubectl. Can I impersonate anybody even if I don't have any privileges?
Great question.
And what do I need for these?
Yeah, that's a great question. With kubectl auth can I, that tool comes with the subject access review permission. So anyone can run that as themselves if they're authenticated in a Kubernetes cluster. That's a default permission. But if you're trying to impersonate someone else, that's an additional permission. I'm not sure which default role grants that by default, but it is an additional permission to be able to run it as someone else.
Next.
If you're using OPA or similar on top of the default RBAC stuff, are there any tools that help make the layered decision analysis easier?
Sorry, can you say that again?
If you're using OPA on top of RBAC to do finer-grained access control, are there any tools that make it easier to say what got rejected, why, and where?
Yeah, that's a great question. So he's asking about, if I understood it correctly, he was asking about if you could use Open Policy Agent to use more granular policy when it comes to RBAC. Is that correct?
Yeah.
Okay.
Any tools that help?
Yeah, and if there are any tools that help. I don't know of any tools in particular that help. There are some Open Policy Agent webhooks, which would allow you to create an Open Policy Agent on your own and open Policy Agent configuration on your own and prevent any kind of actions from happening. Webhooks are really, really amazing. It's basically free form, but you can write OPA policies to do auth. I don't know of any specific tool that helps you do that that's auth focused. Yeah.
Thank you for this compilation of tools. I keep thinking, do you know if those tools have a kubectl plugin? Because they are they are just one step away, right? And for me, a kubectl plugin would mean a more natural flow.
I'm not 100% sure about kubectl who can. I know Reques is known as Access Matrix if you use Crew as a plugin manager. And RBAC lookup is known as RBAC lookup within Crew. But they are both available as kubectl plugins as well. Yep.
Thank you. Actually, I must confess that it's not a question. It's more like a general comment. Just as a security guy, I cannot stay silent. So first of all, I need to thank you because this was very impressive and very useful presentation and demo. But I couldn't just. It was like a splinter in my mind. Why do you grant access to individual users? Why don't you grant access to groups of users? Is it for demo purposes, or this is the way you do?
That's a great question. It depends on how the users come into your system, essentially. So your authentication provider, when someone is authenticating into your user, into your cluster, can provide a username and an optional list of groups. Some authentication providers support groups, others don't. The one thing that is always provided is a username. So groups, when they're available, are awesome, but they're not always universally supported. So it just kind of depends. But that's a great point. If you do have groups available to you, definitely use them.
Thanks a lot for this presentation. Now we know everything about everybody's access to the cluster, but do this tool work with service accounts?
So, yes, absolutely. Service accounts are listed in output for all of these. And even RBAC Manager, I didn't cover that specific component. It was too short of a talk to cover everything, but RBAC Manager does also manage service accounts for those use cases as well if you want to.
So you gave what permissions are required for kubectl CANI. Do you know what the permissions required for the other 4 tools are?
Yeah, so RBAC Manager is an operator that's deployed into your cluster. And because it's creating role bindings and cluster role bindings for you, it needs to be able to create cluster role bindings and role bindings for you. And it also needs to be able to watch namespaces for changes. kubectl who can, I'm not as familiar with that tool. RBAC lookup is just read-only access on RBAC resources such as role bindings and cluster role bindings.
Yeah. Will these tools enable multi-tenancy?
Not necessarily, kind of. They can help in that process, but there are other limitations currently in Kubernetes where there's a lot of work going on to help make multi-tenancy more feasible. But this would be more helpful towards maybe soft multi-tenancy. But for true multi-tenancy, we need additional tooling and ways to restrict access between namespaces that aren't currently perfect. So there's work going on, but I wouldn't say this on its own can get us to that perfect multi-tenancy point.
So what are those tools?
As far as working on multi-tenancy, I guess tools isn't the right term. It's more work inside Kubernetes itself. There's a multi-tenancy working group that's doing some awesome stuff to try and help simplify that process and help get to a more secure state. But I don't have great resources beyond that.
Hello. Yeah, I'm here. Do you plan to have label selector at pod level?
Sorry, say that again?
Do you plan to have label selector at pod level, not namespace level?
An inspector for a pod? Label selector. Oh, gotcha. Yes, sorry. So label selector is something that we initially only supported for namespaces. It's a little bit trickier when it comes to other Kubernetes resources because role bindings by default are something that can be granted at a namespace level. There are specific ways to grant specific resource names, but that gets a little stranger, and that's something that's not in role bindings, that's in defining the roles themselves. So we kind of have to change how RBAC Manager works. Right now it's just focused on managing role bindings. And we can do namespaces that way, but it's harder to do resources themselves individually.
OK, we're out of time. Thanks, Rob.
Thank you.